In section 3.3, we start looking at systems of inequalities and what it means to solve a system of inequalities. So we are going to look at, again, what it looks like to solve a system here. With example 1a, we're going to solve by graphing. Now really, solving by graphing is probably the easiest way to solve a system of inequalities for reasons that I'll explain a little bit more as we go through this first problem. So example 1a, solve by graphing. Let's solve our system of inequalities. X plus 2y is less than or equal to 4, and y is greater than or equal to negative x minus 1. First of all, before we get started, just like when we were solving a system of equations by graphing, the first thing we really wanted to do is to get both of our equations in slope-intercept form. In this bottom one, this bottom inequality looks like it's slope-intercept form. We still have y alone on one side, and then the rest of our equation. We have our x, and then we have our v value. So we need to do the same thing up here with our top equation, our top inequality. So I'm going to start off by subtracting x from both sides. And then dividing by 2. Two minus 1/2 x. All right, so I'll underline here my two inequalities that I'm working with. When I graph my inequalities, we graph basically the same way that we would graph a line, the equation of a line. Okay, and this should give me enough room. So I'm going to start off with my first inequality here. Y is greater than or equal to negative x minus 1. I start off at that negative 1 with my y-intercept. And then my slope is negative 1. And I can connect these dots with my straight edge. And one thing that you might not remember about graphing inequalities is that this symbol tells us what type of line to use when we're connecting our dots. When we have the greater than or equal to option, we use a solid line. And if it was just greater than or just less than, doesn't have the line underneath, then we would use a dotted line to graph our inequality. Okay, so this is our line, but we want to know what ordered pairs is our y value greater than or equal to negative x minus 1. So there's not just going to be one ordered pair here. It's not just going to be ordered pairs on our line. It's going to be anything greater than or equal to above that. So I will shade this in a little bit. Next, y is less than or equal to 2 minus 1/2 x. And I will use a different color here. My y-intercept is 2. And my slope is negative 1/2. So down 1 over 2, down 1 over 2. And we have a solid line again because I have the less than or equal to option. Okay, and I really should extend this a little bit more, and I'll go back and extend my other line a little bit too, because ideally I want to be able to see where those two lines intersected. Oops. So scratch that. I really need to go even further this way. I should have made my graph a little bit bigger. I'll go back and extend my blue line a little bit here too. Now my green, my symbol is less than or equal to. So I'm looking at my system for this inequality is any point that's below that line. And the solution to my system of inequalities is wherever my shaded regions overlap, because that means anything in this double shaded area, our ordered pair works for both of our inequalities. So I usually like to symbolize that this is my solution by writing an S in that double shaded region, just to know, hey, this is what we're looking at. This is actually our solution. So again, if I pick any ordered pair in this double shaded region and plugged it in to both of my inequalities for x and y, both statements would be true. And that's why when we have a system of inequalities, it's not just one ordered pair that we're looking at. There's really an infinite number of ordered pairs that are solutions. I guess there's really a couple last things that I want to add as far as notes for this example. The first thing is the fact that if we have a greater than or equal to symbol or less than or equal to symbol, we use a solid line. Plain old greater than or less than, use a dotted line. And then the last thing that I want to add is that while we are solving one of our inequalities for y, while we're trying to get y by itself and change into a slope-intercept form, if in that process we ever have to divide or multiply both sides by a negative number, don't forget that we have to flip the direction for this inequality symbol. So I'm going to add that here too. If you ever have to multiply or divide by a negative, flip the inequality symbol. Okay. And this is very, very important. That might be the difference between you getting no solution when there really is a solution or crazy things like that. So just be careful with